Hugging the remote control and flying the plane, what does it feel like? This is the ground effect vehicle we designed and built. You heard that right, it can carry me to fly over the water. From design and production to successful test flights, we spent more than 3 months on this project. But the story actually starts 4 years ago. On the banks of the Ganjiang River, I tested my first low-efficiency flying vehicle that I had designed and built. At first, it didn't meet expectations, but after a week of optimization and upgrades, the second version almost achieved ground effect flight. This is also my first viral video, which many of you started following me for back then. Since then, I've always had the idea of creating a ground effect vehicle. However, due to high production costs, it remained just a concept on paper, buried at the bottom of a box, until 4 years later when, with the support of Insta360, the idea became a reality. This new design is quite different from the original one. It features a front and rear wing configuration. Initially, I considered paying tribute to the Soviet-era Lehigh Monster, but based on my previous test results, I realized that this aerodynamic shape would struggle to maintain altitude and stability without a flight control system. So, I abandoned that idea. The propulsion system is the same as before, with 4 large motors at the front, and the flight control relies entirely on differential motor thrust, eliminating the need for control surfaces. I based this design on successful case studies, and it is definitely feasible. I also created a 1% scaled model for testing, and the prototype of the ground effect vehicle showed no flight control issues. Even with 4 heavy bricks attached, it remained stable. The initial design had a boarding ladder at the rear with 2 small vertical stabilizers serving as handrails, giving it a yacht-like feel. In the Wolf Warrior version, I removed the ladder and replaced it with a single vertical stabilizer. This is the final design for our Wolf Warrior DMA flying vehicle. The wings and main body are made of KT foam board, with multiple layers glued together for strength. I know some of you may wonder, aren't you worried the wings will break? Of course I was concerned. So, I specially ordered 8 thick carbon fiber tubes to support the structure. After testing the strength, I found it to be more than sufficient. The connection points were further reinforced with aviation-grade plywood. To ensure assembly precision, we used a brick frame for the first time, and all the assembly work was done on this frame. Once the first wing was completed, I discovered a problem. The leading edge skin would sag. Although this didn't affect its function, it didn't look good. I redesigned it, adding extra support, and the final result was perfect. The main body is made of 5 cm thick strong thermal insulation board with a hollow core, combined with fiberglass composite materials. The power system is critical for takeoff, requiring a 3-meter-long fixed link. A lightweight aircraft wing spar is a perfect fit for the structure. We used 3D printed parts to connect the motor and aluminum tube, which were reinforced and tested for strength. The finished product looks especially cool. Its size is quite large with a 4.8-meter wingspan. It can carry up to 64 kilograms. From the first wings production, the 4 of us in the workshop worked for over a month. This was the largest project we had ever undertaken in terms of scale and engineering. All production was completed in a room on the 4th floor. Getting it out the door was a big challenge. The wings barely fit through, and the body had to be disassembled and carried down the stairs. Luckily, the body is made of foam board, so its weight wasn't too extreme. Next came the thrilling test flights. Local aviation enthusiasts knew I was planning to fly again and showed up to watch. Earlier tests with small-scale models had failed, so we were especially cautious during this test. We started with several hours of ground testing before attempting full flight. After everything was ready, we were able to take off. Watch as the test flight unfolds. The low-efficiency vehicle uses a 50V 160 mAh battery, which only allows for 10 minutes of flight, with charging taking about an hour. We tested for 2 days in the sun, collecting a lot of key data. The ground cruise speed is about 48 km per hour, and it can reach a maximum of 53 km per hour. The throttle was mostly at 60%, and there was still a lot of excess power. The flight range with one battery is about 3 km, which is a bit short. We also tried using excess energy to fly, but it couldn't fully leave the water. This may be the first all-manual ground effect vehicle in China. I finally fulfilled my dream of flying a plane while holding the remote. But this is just the beginning. I will continue to optimize the design, replacing the electric motors with a gasoline engine to extend the range to 10 kilometers. I also plan to improve the flight control system, adding control surfaces to increase flight stability and safety. Currently, this vehicle is built with the most basic materials such as foam board and cheap components. Some parts may pose safety risks with long-term use, but I plan to upgrade it all to carbon fiber composite materials. My plan is to design and develop it into a new type of single-wheel watercraft. Maybe one day such flying vehicles will become a common mode of transport. I'm Pudding and I'll see you in the next video. Bye-bye.